Hey everyone, this video will be on a mathematical guide to simple linear regression. So firstly, the mathematical definition of a regression model. Suppose we have the weights and heights of n equals 6 aliens. We'll let y1, y2 up to yn be their heights. Since n is equal to 6, we'll have up to y6. Similarly, let x1, x2 up to xn be their weights. A linear regression model predicts a height yi hat from weight xi as yi hat is equal to beta naught plus beta 1 times xi. This is for some choice of numbers beta naught and beta 1. So what is beta naught? A simple linear regression model predicts a height y hat as y hat is equal to beta naught plus beta 1 times x for any weight x. This is the same as before, except we removed the I subscript. Sometimes you need it, others you don't. Now suppose x is equal to 0, so some alien weight is 0. Then y hat is equal to beta naught plus beta 1 times 0, which is equal to just beta naught. This means beta naught is our predicted height when weight is equal to 0. Now what is beta naught visually? Suppose we have our aliens, so the first alien has a weight of 10 grams and a height of 18 centimeters. We'll put this data on a scatter plot, weight on the x-axis, height on the y-axis, and our first point here has a weight of 10 grams and a height of 18 centimeters. Here's the rest of our alien creatures in red, and we'll draw a line through it, which is our linear regression model. To visualize what beta naught represents for this model, suppose we have a new alien that has a weight of 0 grams, and this is equal to x, it's our input. Then the height for this alien, well, so far we're not so sure. We draw our line up from the x-axis, where weight is 0 grams, and see where it intersects with the blue line. It intersects with our model at a height of 9 centimeters. So for an alien with a weight of 0 grams, we'd predict their height is 9 centimeters. And we denote this as y hat, it's our prediction. Since this is a special case where x is equal to 0, y hat in this case is also equal to beta naught. So beta naught is what we call the y-intercept. It's where the model intercepts with the y-axis, which in this case was at 9. Now what is beta 1? The mathematical derivation is a little annoying, so we'll skip it. Beta 1 represents the slope of the line. So what is beta 1 visually? Well, we need to understand what slope means. Here's our same graph as before, but with a couple changes. We're only looking at the weights between 1 and 3.5 grams, and we're only looking at the heights around the 9 centimeter mark. If we draw a mark up at 1 grams and then across, we see it hits a height of 8.6 centimeters. To measure slope, we need to go 1 unit across in the x-axis, so now we're at 2 grams. This is 1 unit over in the x-axis. If we draw our mark up from here, measure the intersection with the line, we see that it hits at roughly 9.1 centimeters. We now need to measure the increase in height that we got. So we started at 8.6 and we went up to 9.1. So this is a 0.5 change in the height. This is not yet the slope. We calculate slope as rise over run. Rise is the increase in the y-axis, which is 0.5, and run is the increase in the x-axis, which is 1. So we have slope is equal to 0.5 divided by 1. This simplifies to simply 1/2 or 0.5. As we said, beta 1 is equal to the slope. So for our model, beta 1 is equal to 1/2. Since the slope of a line is consistent throughout the entire line, what it means is that for any 1 unit increase in the x-axis, we'd expect an increase of 0.5 in the y-axis. Now let's get some regression predictions. Here we'll bring back our graph as before with its original axes and draw the line through it. Suppose we had a new alien that has a weight of 40 grams, but before we could measure its height, it teleported away, so we need to predict its height given its weight. We draw a line up from 40 grams on the x-axis and see where it intersects on the y-axis, which is at 29 centimeters. But this is done visually. We'd much rather it was done mathematically on the left. Our prediction y hat is equal to beta naught plus beta 1 times x, where x in this case is the weight of 40 grams. We calculated from before that beta naught is 9 and beta 1 is 0.5, so here's the same thing, but with each of those substituted in. This further simplifies to 9 plus 20, which is equal to 29, which is what we had visually as well. So for an alien with a weight of 40 grams, we would use our model to predict its height is 29 centimeters. Okay, a couple notes before we go. A simple linear regression model predicts a height yi hat as yi hat is equal to beta naught plus beta 1 times xi for some choice of numbers beta naught and beta 1. Whereas a multiple linear regression model predicts a height yi hat as yi hat is equal to beta naught plus beta 1 times xi1 plus beta 2 times xi2 plus all the way up to beta p times xip. This is where p is the number of input variables we have. We're not supposed to understand this quite yet, but simple is where you have one predictor like the weight, and multiple is when you have multiple predictors like weight, color, eye color, and so on. That's the end of this video.